So what is it we're talking about when we say stainless steel? There's of course a wide variety of grades that are called stainless steel, but the general basic requirement is that it has at least about 10 to 12% of chromium in the alloy. Many have more than that. Chromium imparting its corrosion resistance to the alloy in general. You'll also see in some grades, the austenitic family of grades, a high amount of nickel, and then other metals, molybdenum, silicon, manganese, copper, tin, also carbon, of course, added in varying amounts depending on the exact grade, what kind of properties you're looking to achieve with the steel in the application that it's going into. But of course, always remember that most of the metal in the alloy is still iron, generally about 70%, and it is the iron that will create the rust in a corrosive environment. All throughout the metal, even on the surface where it's important, it is 70% iron until it's passivated, and so that's what the chemical treatment is to take care of that. It is the chromium and the nickel and the other things that determines ultimately just how corrosion resistant the alloy is once it's been passivated. The more of the non-iron things you have on the surface, then the better off it's going to be in a corrosive environment. Stainless steel is used anywhere that some degree of corrosion resistance is required, when you also have the need for the structural strength and the low cost of steel, which is widely used in a lot of things. Every industry uses stainless steel in varying amounts and grades. Sometimes a lot, sometimes only a little bit in the tiny parts, deep down and inside of a mechanism. The big problem with stainless steel, though, obviously, is that since it is still mostly iron, it can still rust and corrode. Sometimes because the surface has been contaminated by an external source of iron, often during the manufacturing process or during the transportation, or if the surface has been stressed with chlorides and other chemicals, chlorides coming from swimming pools, ocean environment, cleaning the surface repeatedly with bleach, that type of thing. There's a lot of things that can stress the surface. The cost to attain a high degree of corrosion resistance can be a lot, especially in today's market where you have an increasing shortage of chromium and nickel and the other important metals that go into getting the properties that you need. So quality problems are growing. Stainless steel isn't always what it used to be. The grades themselves, of course, the austenitic grades, like I said, has higher chromium and higher nickel, so they're much more corrosion resistant. These are the 300 grades. You'll see those a lot. Tanks and pipelines are almost always the 300 grade. Over in the medical, surgical, blades end of things, you'll see more of the 400 grades. These are the martensitic and the ferritic, with no nickel, lower amount of chromium, and what the trade-off there is, these are hardenable alloys, so that you can get the hardness that you can't get with the austenitics. So you're losing a bit of corrosion resistance, but you're getting the hardness that is required to maintain the blade for whatever purpose it's being used for, surgery or something else. So there's always an alloy selection, and usually the customer already has the alloy that they're going to be using for their product or the product they're making for somebody else, and it's just a matter of matching that to the proper process. But you'll see a pattern of the different grades and families of grades being used in specific industries. So rust prevention and general passivation, of course. As I said, some grades of stainless are more corrosion resistant than others, and you always have to keep that in mind. A 420 or a 416 grade is never going to be as corrosion resistant as a 304 or a 316, so you can't expect it to. But if you're sticking something out near the ocean and you want to make sure it's as corrosion resistant as possible, then you're going to want at least a 316, maybe even a duplex grade, and the cost goes up, but you get more corrosion resistance in exchange. The source is also critical. If you want to be certain of a high quality metal, it's important that it's coming from a high quality source. The US, Germany, Austria, Sweden. There are other, Far East type sources. May or may not be the exact composition, etc. That is optimal for high corrosion resistance. Passivation process, obviously that's why we're here. That's removing iron from the surface, giving you a higher chrome oxide layer there for protection against the corrosion. Post-treatment, not really that often used. It is mentioned in the standards. This is generally going to be either sodium dichromate, which is hazardous, so you really want to stay away from that, or it can be a peroxide, which can be used in a bath to boost the oxidation rather than the normal natural formation of the oxide layer in the air afterwards. Stressful environment, obviously, sometimes it can't be avoided, but if in certain situations, certain applications where you can keep the chlorides off, switch to a cleaner that isn't high in chloride, then that's helpful. If it's something near the ocean, rinse it with fresh water every now and then to get some of the salts off, and then just properly maintain it. If it is in a highly corrosive environment, then you just want to keep an eye on it always, and when that rust starts to appear, remove it right away and repassivate so that you keep that surface looking good, because if you let it slide, the worse and worse it gets, the harder it's going to be to get it back into a good condition.